Determine whether the integral is convergent or divergent, and evaluate if convergent. Here we have the integral from negative infinity to infinity, y cubed minus 2y squared dy. This integral is an improper integral. We have infinite limits of integration in both places, actually. So we have to use the definition to evaluate this thing. So this becomes the limit as a approaches negative infinity, the integral from a to, say, 0. You can essentially pick any number in between negative infinity and infinity to break this integral up. Y cubed minus 2y squared dy plus the integral from 0 to positive infinity, y cubed minus 2y squared dy. We have the limit as a goes to negative infinity, the integral from a to 0. Oh, sorry. We can actually integrate that out without any trouble. It's simply an application of the product rule, power rule in reverse. So y to the 4th over 4 minus 2y cubed over 3 evaluated from a to 0 plus the limit, oh, pardon me. This should be the limit as b goes to infinity of the integral from 0 to b. Okay, so the limit as b goes to infinity, integral from 0 to b, we'll go ahead and integrate that, just as we did for the other one. Y to the 4th over 4 minus 2y cubed over 3, 0 to b. Now for this first limit, we plug in the 0 first. So the limit a goes to negative infinity, 0 to the 4th over 4 minus 2 times 0 cubed over 3, which of course all of that is 0, but just to make it clear, a to the 4th over 4 minus 2a cubed over 3. Similar thing for this second one. This is going to be the limit b goes to infinity, b to the 4th over 4 minus 2b cubed over 3 minus 0 to the 4th over 4 minus 2 times 0 cubed over 3. Okay. As we already said, 0 to the 4th over 4 minus 2 times 0 cubed over 3 goes to 0, so that simply goes away. This next term, a is getting closer to negative infinity. Well, if you take, so a is a very large negative number, if you will, and it's getting larger and larger. If a is negative, it doesn't matter for the 4th power, because the 4th power will take a negative number and change it positive. The point is that it continues to grow larger, so this gets closer to positive infinity. Even after you divide by 4, nothing really major happens there. However, a cubed does something. If a is a negative number, a cubed will also be a negative number. And so the two negatives will make a positive. Okay? A is also getting larger. Now it's getting larger in the negative direction, but it's getting larger in absolute value. And when you cube something like that, it gets larger as well. So in fact, this term also goes to infinity. And when you add those two infinities together, you get infinity. So in the next line, we have that, excuse me, let me make sure. Wanted that to be black. In the next line, we note that we have 0 plus infinity there. Well, that already tells us that when we broke up our original integral into two integrals, namely this one and this one. If either one of those integrals diverges, then the whole thing diverges. And we just found out that the first one does indeed diverge. So the integral from negative infinity to infinity, y cubed plus 2y squared dy diverges.